In this video, I will talk about data classification. We will talk about how to distinguish between qualitative data and quantitative data, and how to classify data with respect to the four levels of measurement. We have nominal, ordinal, interval, and ratio. So qualitative data consists of attributes, labels, or non-numerical entries. For example, your major, your place of birth, and eye color. Some other things that will be considered qualitative, even though they deal with numbers, would be zip codes, social security numbers. Those have numbers, but you can't do anything with those numbers. You can't add zip codes together or subtract them or what have you. But so those will be considered categories or qualitative data. Quantitative data will be numerical measurements or counts. For example, your age, the weight of a letter, and temperature. Those all deal with numbers. So let's look at this example. The table shows sports-related head injuries treated in U.S. emergency rooms during a recent 5-year span for several sports. Which data will be considered qualitative and which ones will be quantitative? So if you look at the table, you have sports, basketball, baseball, all the way down to volleyball, and then we have the number of head injuries treated for each sport. Okay? So it looks like basketball has the most head injuries, volleyball has the least. So the qualitative data, or the categories, will be the type of sport. The head injuries deal with numbers, so those will be quantitative. Now let's talk about levels of measurement. We have a nominal level of measurement, and that deals with qualitative data only. It's categorized using names, labels, or qualities. Non-mathematical computations can be made. No mathematical computations can be made. Ordinal level deals with qualitative or quantitative. The data can be arranged in order, but the differences between the data entries is not meaningful. So let's look at this example. We're going to determine whether or not it's nominal or ordinal. So the first one is the top 5 U.S. occupations with the most growth, projected for 2024. And then we have movie genres. Okay? So these are ranked data. As you can see, it looks like the number one top occupation would be personal care aides. Number 2 would be registered nurses, all the way down to 5, which is retail salesperson. And then for the movies, we have action, adventure, comedy, drama, and horror. Well, the first one would be ordinal, because you can rank the 5 largest job growth occupations. But the differences between the ranks is not meaningful. The movie genres would be considered nominal. They're just categories, and you can't do any mathematical computations on these, and they cannot be ranked. Now let's look at interval. That deals with quantitative data. The data can be ordered. The differences between the data entries is meaningful. 0 represents a position on a scale. It's not an inherent 0. 0 does not imply none. Then we have ratio, and it's similar to interval. A 0 entry is an inherent 0. That implies none. A ratio of 2 data values can be formed. One data value can be expressed as a multiple of another. So let's look at this example. We want to see which ones are interval and which one will be ratio. So the first one talks about the New York Yankees World Series victories. It has the years. So these are the years they won the World Series. Over here on the right, we have the number of home run totals by team in 2016. Okay. So let's see. We can say that the number of World Series victories will be interval. It's quantitative data, as you can see. You can find the difference between the two dates, but the ratio does not make any sense. And I'll talk about ratios in a few minutes when I do another example. In this one, this will be the home run totals will be ratio. You can find differences between the two data values, and you can write ratios. So here's a summary of the 4 levels of measurement that you can look on your own. It'll tell you whether or not you can put in categories, if you can arrange the data in order, if you can subtract data values, and determine if one data value is a multiple of another. So let's go over some more examples. In this one, we have a nominal level. Remember, that deals with categories or qualitative data. And this one is the type of shows televised by a network. So you got comedy, drama, all the way down to talk shows. So these are categories. A show televised by the network could be put into one of the 8 categories shown. The next one is an ordinal level. This pertains to qualitative or quantitative data. And this one talks about the Motion Picture Association of America ratings description. So you can put these in order. You can put ratings in order. So for instance, a PG rating has a stronger restriction than a G rating. So that would be ordinal. When I think of ordinal, I think of order. In this next one, we have the average monthly temperature in degrees Fahrenheit for Denver, Colorado. So this is interval. You can put the numbers in order, and you can find the differences between the two data values. So for example, you have a temperature of 72.5. You can subtract off the temperature of 63.4. 72.5 was August, and you're subtracting September, 63.4. So as you can see, it's a 9.1 difference in temperature. So August is 9.1 degrees warmer than September. The next one is ratio, and this is the average monthly precipitation in inches for Orlando, Florida. So once again, this is quantitative data. You can put these in order. You can find the differences between 2 entries, and you can find ratios. So if you look here, 7.58 pertains to June, and 3.77 pertains to March. So a ratio is basically a fraction. When you divide this out, this is approximately 2. So there's about twice as much precipitation in June as in March. So that's what I mean by ratios. For the interval doesn't, you don't have to start at 0 when it comes to interval data. If you go back to this definition that I had up here, 0 represents a position on the scale. It does not imply none. So when I think of interval, you can also think of temperatures. Temperatures can go below 0. So interval does not have a starting point of 0, because you can have negative temperatures. Temperatures is considered an interval value, as you can see in this example. So you can have, well, I'm in Chicago, so we have like negative 50 degrees here in the winter. So your interval data it's not you don't have to have a starting point of 0. Okay, that's the end of this lecture.